Welcome to this video blog. I'm Chris Yates of ice-berg. In this video we'll be talking about infiltration, ventilation and some options for modelling this in ice. So what is infiltration? Infiltration is a category of ventilation. The other categories include natural ventilation and mechanical ventilation. And we can think of infiltration as unintended ventilation. We have ventilation that's intentional, for example from opening a window or from running a ventilation fan, and then we have infiltration, which is more of a side effect. Infiltration comes from multiple paths through defects in the building, poor sealing around windows and doors, masonry, porous masonry, cladding junctions. I've even seen it come from plug sockets, believe it or not. Natural ventilation, of course, comes from opening a window or some kind of natural ventilation louver or some kind of passive vent or stack vent. And then, of course, mechanical ventilation comes from running a fan, either a standalone fan or a fan in an air handling unit or MVHR unit. But the crucial thing is they're all coupled. They all interact. Natural ventilation and infiltration are largely governed by temperature differences, stack effect and wind pressure, but they all interact. HVAC pressure can also drive both infiltration and natural ventilation, and this is where IDA is quite unique in modelling this coupling and interaction. You may be familiar with software such as IES, TAS or Designbuilder. They all have different ways of implementing infiltration and ventilation. IDA has quite a unique paradigm in this respect, so let's dive straight in. So we are looking at the small office model, which is a sample BIM import project model, and we can we'll open two zones that we've helpfully called outer and inner, and then we will open the permeability and infiltration panel. We'll get it all organised on screen, and I want you to focus on these fields here. They're the leak area and the given additional infiltration and exfiltration. So we'll just reorganise again, and these are linked now, so you may want to stop or slow down the video here to see the effect of me messing around with the infiltration settings on the zones, leak and additional infiltration settings. So the default is like passive house air changes. It's like the the N50 in passive house, and we can use network airflow, and we can also revert to fixed infiltration. And if we revert to fixed infiltration, the effective leak area becomes numerically small at 1 × 10⁻⁴, and we get this given additional infiltration, exfiltration. But ultimately, I think what we'll do is change the units to something familiar in meters cubed per hour per meter squared, and revert to something we recognise, and 4.5, setting of 4.5. And let's have a look at the effect of this. Oh yes, also before I forget, we need to set the AIVC pressure coefficients, and once we've done that, everything's set up. We'll just set them to a standard semi-exposed value in here, and then we can run a simulation. So first of all, we need to choose some output, and we will choose wind speed and airflow in zone, and I think we might need ventilation airflows as well, and then we can simulate. Simulation finished, so let's go and have a look at one zone at least. If we check out the results, have a look at airflow in zone, we can it's quite a lot of data. Perhaps if we look at a week, we look at outflow and inflow. So this is all coming via the leaks in the facade that we saw defined earlier, and yeah, the rates aren't necessarily concurrent. It's all the different kinds of pressures are at play, and it's not a fixed 0.25 air change rate, as you can see. But looking at all this data, it's not always the easiest to digest visually, especially in a YouTube video. So let's do something a little bit more visual. Let's go to the 3D view and do some animations. So close this to start with. Open the animation panel, and we can look at inflow or outflow. It's in litres per second per metre squared of floor area, so I need to, instead of just using the default scale, I'll set this to something quite a bit smaller, so maybe 0.5, and we can animate the wind speed on top of this as well. So what's this? Wind is largely coming from the north. We've got outflow. This is exfiltration we're talking about now, outflow. So quite a lot of the time there's zero exfiltration, but it depends on wind speed. If I just try and get some time slices here. So what have we got? We've got a northerly wind. We have got zero outflow on the northern side, and obviously outflow on the lee side. Let's go for an alternative animation. So if I go to ventilation airflows, this overlays all the different airflows. It's that kind of rendered arrow. So, and again, yeah, you can see if I just flip to the top view, you can see we've got inflow, northerly wind again, and inflow on the northern facade and outflow on the south facade. Okay, so I'll just switch the rest of the building back on now. There we go. Don't think this is, let's just play this. There we go, we can look at different time slices or animate them. It's all a bit busy and confused, but you can home in on specific spaces and then, look at the data itself. As you've seen, the data will export out into Excel as well. In the real world, infiltration is coupled with other categories of ventilation, such as opening windows or HVAC. Infiltration is affected by pressures generated from HVAC. So let's model that. We can do a 10% oversupply and some localised extract. Now, both of these, the oversupply and the extract, are trivial situations in HVAC. They are ubiquitous, but they're not trivial to model, except in ice. So let's do it. First of all, let's model this 10% oversupply, and then we can model the extract. So I will. Okay, so there's the 10% oversupply. Then I'm just going to turn off the ventilation in this. I'm going to pretend there's an extractor fan in here, and I'm just going to do that by zeroing the supply. I could actually do this some other way, but I'll just zero out the supply. And then this, let's say this is 20 litres per second. So that's giving us 8 air changes. I might drop that a little bit. And so what it's going to do is I'm going to suck out air out of here. I'm going to drag it through this door, which has some leak area. It's going to drag it through this room and through the facade. Now the facade the leak area is about an order of magnitude too small, really. I think we'll end up with some quite high pressures in here, so I can either just take that out, you know, and make that a 0.01, you know, or what I could do is open up this wall and add let's get my little panel back, and add some kind of extra leak to it, which will be 0.1, so that's got an extra little leak in it. Right, so that's all set up. Again, let's simulate it. And here we are back in our 3D view, so let's take a look at what effects this has had. Let's open up an animation. We'll look at inflow through external walls overlaid with wind speed. And everything's fairly stable. Yeah, the wind speed's changing. I'm animating this, but it's all pretty static, and actually all this dark blue is zero. It has, well, apart from this zone here, there is zero, or pretty much zero, effectively very little inflow through the external walls, as we would expect, because there is 10% oversupply of supply air. Apart from, of course, this outer zone here, which is the kind of intake plenum, if you like, for the inner, you know, kind of extract space, this WC. So that seems to be working. Let's try the looking at the opposite of this then. Let's have a look at outflow. Okay, there we go. It's a little bit more variable, but essentially we're in fairly persistent outflow. I should probably change the scale a little bit, but rather than that, let's just look at the ventilation arrow rendering ventilation airflows. Let's try this. Okay, so there we go. So you can see this ventilation arrow is centered on the leak that I placed in the wall. So we could say it's intentional rather than unintentional airflow. So maybe it doesn't fall within the category of infiltration, this here, because it is the airflow path that we've intended to go all the way through this zone here into this zone that's being extracted from here. But our zones are pretty much persistently in exfiltration rather than infiltration. I'm sure if we checked the you know, the graphs for any of these individual zones, with the exception of this kind of outer plenum type zone, we would see that we're pretty much permanently in exfiltration in this building now because of the 10% oversupply. Like I said, this is a fairly trivial and ubiquitous situation in many buildings, but it's actually quite hard to model in most tools apart from ice. So I hope that you have enjoyed this video. Thank you for staying with me for this length of time, if you have indeed done so, and I'll see you in the next one. Bye for now.